Hello and welcome. This is the fourth video from Darton College Science Department's Flipped Learning series from P3 Unit Forces in Motion. This video is on speed time graphs. Right, the aim for this video is that by the end of it you should be able to explain what the gradient of a speed time graph shows, i.e. how steep it is. We should also be able to draw and interpret speed time graphs, and you should be able to calculate acceleration from a speed time graph and also distance. Because you've already seen how to calculate acceleration, you might want to try these two questions below yourself before I go through them. First thing to do, to calculate average acceleration, you need the change in speed divided by the time it takes. So for a normal car going 0 to 60, which is 27 meters per second, it takes about 9 seconds. It takes 8.95 seconds. So the change in speed divided by the time taken gives you the acceleration. So a normal car accelerates at roughly just over 3 meters per second squared. A supercar will do the same journey, the same acceleration, 27 meters per second, but do it in 2.46 seconds. That gives an acceleration rate of much higher, nearly 11 meters per second or meters per second squared. So a supercar will accelerate much quicker than a normal car to get to the same top speed. In both of those questions we assumed that acceleration would be a straight line, when in reality what will probably happen during that acceleration is that we'll get a less straight line where there are periods of acceleration, faster acceleration, slower acceleration, even deceleration maybe on gear changes. But we assume, for ease of calculation, that we have a straight line acceleration. This can be transferred to a graph just like this. The slope of this line indicates acceleration. The steeper the line, the faster the acceleration. So acceleration in this graph here is faster than acceleration in this graph here. This is different from a distance time graph, and you must be really careful to not get the two confused. When you move on to the third graph, a downward sloping line is showing deceleration or negative acceleration. Two other things you need to be aware of. A horizontal line shows a constant speed. That's different from in a distance time graph, because a horizontal line in that would show stopped, but it's a constant speed in a speed time graph. And you would also have a flat line at 0 would show something stationary. It's really important that we don't get the two things confused, the speed and the distance time graph. If you want to work out acceleration here, we need to work out the gradient or the steepness of the line. If you remember, you do this by constructing a triangle. You need the triangle's height, which in this case is 45, and the triangle's base, which in this case is 55. So if we're going to do speed divided by time, or change in speed divided by time, what we can see here is the gradient of this line gives us the rate of acceleration, which is 0.81 meters per second squared. So if we had to construct a speed time graph looking at this data, we've got a steady increase in speed from 0 to 18 meters per second. So let's say that takes 5 seconds. That puts our point there. Then what we need to do is join these 2 points up using a straight line, because it's steady speed. It says then constant speed of 18 meters per second. Shows a horizontal line, and then we've got a steady decrease in speed from 18 to 0. So that shows braking or negative deceleration. Right, as well as using the gradient of a line to calculate acceleration in a speed time graph, you can also work out how far someone has travelled by calculating the area underneath the line. The best way to do this is divide it into regular shapes and then calculate the area of all the shapes involved. I'll show you what I mean. So here's a journey. If we divide this up, let's look at this line, we can work out the distance it's travelled. Firstly, thing to do is let's divide this up into some regular shapes. We've got 2 triangles and a rectangle. Then what we need to do is to work out the area of each of these shapes. So let's call this shape A, B and C. Shape A is a triangle that is 10 seconds across by 7 meters per second high, but it's a triangle, so the answer 70 needs to be divided by 2, gives me 35 meters. The square here, or the rectangle, has a height of 7 and a base of 20, which gives 140 meters. And the triangle here has a height of 7 and a base of 20, but because it's a triangle, it gives us a we have to divide our answer by 2, so 7 times 20 is 140, divided by 2 is 70. And what we've basically done there is divided up into these 3 areas. It's 35, 140 and 70, giving me a total distance travelled of 245 meters in this graph. The last thing that we need to be aware of in speed time graphs is, what does a curving line show? What does the line here show and what does the line here show? Well, this basically shows, this curving line shows he's accelerating to a steady speed. So it basically shows that acceleration has decreased. He's accelerating still, but accelerating slower until he maintains a steady speed between B and C. Between C and D, what we have is rapid braking. That's what a steep vertical line shows. Rapid braking, and then he's continuing to brake, but basically eases off until he's maintaining a lower steady speed. So, in summary, the first thing, the main thing, do not confuse this type of graph with a distance time one. The flat lines, the horizontal, vertical sections mean different things. So, time is always on the x-axis, speed on the y. The steepness, the gradient of the line, tells us the acceleration in a speed time graph. If you've got a graph that is sloping down, that means that something is getting slower. And then where we have a horizontal line, that means a constant speed. The other thing you need to know is that the area underneath the line tells you the distance that has been travelled, and the best thing to do is to divide it up into triangles and squares to help you to work out the area underneath that line. Thank you very much. That concludes the video. Don't forget to bring your evidence with you to your lesson this week on Wednesday. My name is Mr. Cleeth. Thank you very much for watching.